Hey everyone, today we're going to graph a rational function y is equal to 3x minus 5 over x plus 2. Now, if we were to start plotting the points with the function written in this way, we would probably have to make a table of values and plot one point at a time, not maybe really understanding the connection between this function and the parent function y is equal to 1 over x, right? But if we take the time to do a tiny bit of manipulation to this function, we can go ahead and just apply simple transformations on 1 over x, which will probably be a lot easier to put on a graph. So what we want to do is we want to factor out an x plus 2 from this part of the numerator. And to be able to factor it out, we have to make it appear, right? So what I'm going to aim to do is, I know that 3 times 2 is obviously 6. So what I'm going to aim to do is to have a 3x plus 6 in this first part, and then to balance it out, almost analogous to when we complete the square with a quadratic, right? Balance it out so that we still have a minus 5 in the end, right? So, similar to when we're solving equations, we can multiply by 1 creatively. We can also add 0 creatively, right? Whenever it suits us. So let's go ahead and do that. I'm going to add 3x, and then I'm going to add plus 6. But I still want this part of the numerator to end up being minus 5, right? So to balance out the plus 6 and still have it be negative 5 in the end, I'm going to subtract 11 afterwards, right? Because really all I did was write negative 5 as 6 minus 11, right? And now we have that over x plus 2. And now we can go ahead and factor this first part as 3 bracket x plus 2 minus 11 and have all of that over x plus 2. And now, kind of going backwards from getting a common denominator, we can separate these two terms in the numerator over that common denominator. And so we can write it as y is equal to 3 bracket x plus 2 over x plus 2, minus 11 over x plus 2. And the entire reason we did this in the first place was to have the x plus 2's cancel out. So now all we have is, I'm going to reverse this to get it in transformational form right away. We'll have negative 11 over x plus 2 plus all we have left in this term is a 3. And so plus 3. And now that is 1 over x in transformational form, right? What we have is a horizontal translation from the denominator of, flip the sign, negative 2. We have a vertical translation of 3. And we have a vertical stretch of 11 or negative 11 if you don't want to write an Rx, right? And so now we can quickly write a mapping rule from the parent function. Any point on the curve of 1 over x would get mapped to x minus 2 and negative 11 y plus 3. And so if we aim to sketch that quickly on a graph, right, typically we have the points 1 and 1, right? We know that's obviously a point on the original parent function. So the point 1 and 1 going through this mapping rule, 1, 1 would go to 1 minus 2 is negative 1, and 1 times negative 11 plus 3 is negative 8, right? So this could be the first point on our new function. And then we know we also have the point negative 1 and negative 1 on the original parent function. And so we can map that point as well. So negative 1 and 1 is going to go to negative 3, and negative 1 times negative 11 is 11, plus 3 is 14, right? And now we can talk about the asymptotes. So we have a horizontal translation of negative 2 units to the left, and so that's going to be our vertical asymptote over here at negative 2, right? Whereas 1 over x would have that right down the y-axis. And we have our horizontal asymptote, instead of along the line y is equal to 0, it's shifted up 3 units. And so we can maybe put that here. The line y is equal to 3 as our horizontal asymptote. And now you'll notice that we also have an Rx, right? That is a reflection in the x-axis. And so instead of having the regular boomerang, now they're both flipped. So we're going to have boomerang and boomerang. and we can start the process. We still have a vertical stretch of -11, which is significant, of course. And so the first one we have is -1, -8. So that's all the way down here. And next we have -3 and 14. So -3, you know, that's somewhere pretty high up here. And then to graph that from there would just be the regular boomerang shape of our 1/x parent function. But again, this has undergone a pretty significant vertical stretch, right? So it will look like this. And tailing off just underneath the horizontal asymptote, and then likewise for this piece up here, right? Tapering off with the asymptotes. So that's it, we're done. Hope this helps. Thank you for watching. Leave a comment if you have any questions or suggestions, and have a great day.